In this demonstration, I'm going to cover assigning various conveyor types to some sketch geometry that I've modeled here in Rhino. The emphasis of this demonstration is going to fall mostly around the wall and wall by face element types because there's quite a bit of flexibility and nuance to that particular type of assignment operation. I'll also be looking at things like the roof and the floor in this example. So you can see I have a number of different objects modeled here. This is what I would consider to be sketch geometry, articulating a kind of just a design of some kind of building structure. There's some complexity to it in that we have a series of like Boolean slices along the facade and roof. There's irregular geometry, angled geometry, and so on. A lot of the geometry is just simple surfaces that have been modeled up, and there's some interior stuff as well, representing some interior walls, the floor surface and things like that. This might be something that a designer might do up as a quick study during an early conceptual phase of a project, articulating some kind of design concept. And as sketch geometry, what we want to be able to do is start to take this type of loosely defined concept and bring it into Revit, where you might be able to then develop that geometry into actual elements and create different types of documentation. On the Revit end, I have a number of views that are set up, some grids, some section cuts, and so on. So this is already going to be set up to receive some of the geometry from a view organization standpoint. So right now there are no conveyor types assigned to this design. So what I want to do is go through the process of elevating some of this raw geometry in Rhino to true geometry, BIM geometry in Revit, which means I have to go through and do some assignment here. I'm going to start with this feature here. This is a solid object. It's been modeled to have this kind of slice through geometry, and it is clearly an exterior wall, but from an architectural point of view. So I want this to come in as a wall category inside of Revit, and kind of be classified as a wall. This isn't a standard wall type by any means, so I think the approach here is going to be to bring it in and ensure that it just has the wall category to it. So I'm going to select this object, and I'm going to go to my conveyor panel here, and I'm going to make this a wall. I'm going to select the face-based wall. The face-based walls are really meant to be more for complex wall geometry that go beyond just kind of the extrusion type of geometry. So I'm going to select that, and after I've classified that, I then am able to select a type. So this is a solid irregular wall. It's not really going to have a type to it. What I've done is I've created a type just called solid wall, and that's just a kind of a placeholder layer. And what Revit's going to do is it's going to interpret this as a solid and create a solid shape out of it anyway. But by kind of choosing solid wall, I am at least organizing the geometry from other types that might be in the model. So I've done that. I'm going to do something very similar to this roof as well. So I have this solid roof here. I'm going to go to the floors layer. That's where kind of the roof types live, and I'm going to just choose this solid roof type that I've created to kind of hold some of the kind of conceptual solid geometry. So these are now assigned to conveyor categories. So that's easy enough. I also have this piece here. This is I guess kind of like an entryway roof or some other kind of feature object that's sticking out there. I'm also going to go in and make this a roof type and give it the solid roof category as well. So got that. So now we have three objects classified, and these are the kind of more solid types of objects here that are more irregular in nature. I have this exterior wall here. This is a surface. It's planar. and there are some surface segments. You can see these are joined together along these seams, working the way around the building. And what we can do is we can actually use this surface as a driver for a face-based wall. So if you're in Revit, there's a workflow where you might create a mass, a conceptual mass of sorts, and then you're able to apply face-based wall types to the surfaces of the mass. What we can do here is use this surface as a driver for that same operation. So I'm going to go ahead and make this a wall face-based, and I'm going to give this the generic 8-inch masonry type. So this is going to get a generic 8-inch masonry type when it comes into Revit as such. These kind of relief areas here, kind of the push-ins, I want to give a kind of I guess a curtain wall type of classification to it, so it has a glass paneled appearance when it comes into Revit. So I'm going to go ahead and select this kind of inset here. I'm going to select some of these geometries in here. You can see that we have like these punched in windows. I'm going to want to give that kind of a similar type. And I have this like I guess inset area here that's sitting at an angle. I'm going to give that the glass type. You can see that's also connected along this edge here, so you can kind of envision that this is going to be glass running along the edge where this masonry wall comes up. It's then going to reveal have a glass reveal that then touches into the roof. So I'm going to make this a wall face-based, and then I'm going to give this, instead of a basic wall category of the solid wall, you can see that I have this curtain system, a 5-foot by 10-foot curtain system that I can apply to the object. So now we have that type of classification. So what we can expect is that a curtain system is going to be applied to these surfaces. I have this poly surface here. This will also want to be a kind of a wall object. So it's a poly surface. It's got some irregular cuts. I'm going to make this wall face-based as well, and I'm going to give this maybe the generic wall 6-inch classification. And then I'm going to go ahead and hide my roof here, and I have two other elements here. This is there's two extrusions. These are really simple walls, so I can go in and select those. I'm just going to give those the wall category, and I can go ahead and keep that the basic wall generic 5-inch. So I've gone through this exercise now of taking what was essentially conceptual sketch geometry. I've given it some information now that Revit can interpret as different types of classifications, categories, and types that it can use to derive some BIM elements inside of Revit. So I'm going to go ahead and save this. And I'm going to jump back into Revit here. See, I have these views set up. I'm going to go ahead and select the file that I have here. So this is I got a walls 3DM project. I'm going to open that up. And you can see that it's going to give me this element list of objects. You can see we have two solid roof objects as we assign them. We have the two basic wall 5 inches of the interior walls. Then we have a series of face-based walls from curtain systems to solid walls to some of the basic walls that we've done. So I'm going to go ahead and load my objects here. We have 13 objects, and it's going to start working its way through the element table. And this is it tends to be, for this type of model, it tends to be a pretty fast operation. The more time-intensive operations that are going to be occurring here are going to be the wall by face operations. Essentially what Conveyor is having to do is open up Rhino, export some temporary files, open up a massing family, bring those files in, load the mass, and then apply the face-based wall. And sure enough, we have those objects being brought in. You can see that we have a neat little section being cut in this view. And this view already had some of the visual graphic styles set up to kind of hatch in different categories. So it's hatching in the roofs and walls. So it makes clearer sections. We have an elevation here. I'm going to go ahead and go to my 3D view so we can kind of inspect this a little bit. And here is the 3D geometry. you can see that we have a native curtain system that was applied to this particular surface element. What's neat about the curtain system is that if I go into the architecture tab and I do a mullion and I do all grid lines, I can actually assign mullions to all the grids from that face-based mass that was imported in, and I can do the same for this one. And there's that segment there. There's some of these interior insets throughout that I can just start using this geometry as if it was originally modeled inside of the Revit environment, because Conveyor aims to make native geometry as much as possible. Other things that are kind of important to note, you can see that this face-based wall that was driven by that surface was brought in with the type assigned. You can see that we have a basic wall, 8-inch masonry, and we have that particular type being applied, and I can of course change this type. If I want it to be a 4-inch brick wall instead, I can have that flexibility to override it after the fact. Geometry that is not editable but include some of the solid stuff that's been brought in. These objects here that were brought in using the kind of more irregular solid geometry that was defined in Rhino are being brought in as direct shape. But we do have a room bounding wall, so this is classified as a wall. It doesn't have like a wall type to it, but it is classified as a wall. Same with the roof. It has a roof category assigned to it, so it works with visibility graphics. And I'm going to go ahead and go to the plan view as well. So here we have a plan view here with a couple of sections being cut. We can see that we have our walls being brought in. What's neat about this import process is that things like rooms work. So if I bring in a room, all of those objects that I imported in from Rhino are room bounding. So I can place a couple of rooms in my plan view, and we have now some of this rooms that are calculating areas based on the room bounding shapes. So this is a pretty powerful workflow. I mean, the idea here is that we start off what was essentially some sketch geometry inside of Rhino, and as a designer, you may quickly work up a scheme, and then we had a Revit file set up that was able to receive that scheme and host views on to the different sheets. So we have kind of I guess a template set up for the design. It kind of helps to rapidly develop a design in Rhino and then drop it into Revit, which Revit is very good at documentation and sheet management. So we kind of have this scheme now kind of roughed out in the context of the architectural views that you typically want to have: plan, section, elevation, and 3D view, all driven by some sketch geometry that was developed very, very quickly and in a very imprecise way inside of the Rhino environment. So I hope this was a good overview, just in the context of being able to take some sketch geometry, give it some categories, give it some types, and have it generate some native Revit elements.